right, so when you were much younger, how many of you guys either saw TV shows or read books or had a little stuffed animal of Winnie the Pooh?
Probably someone.
A couple people. I did too. Did anybody see the Christopher Robin movie that came out a couple of years ago? Wasn't that like the most adorable thing in the world? Winnie the Pooh was so cute in that movie. Yeah, I really like that one. So, this worksheet is Winnie the Pooh themed. So we're going to go through 3 of these, and then we'll just call it a day for this. So let's start with number 1. I'll give you 3-4 minutes. Try and figure out number 1. We'll go through it, and then we'll go on. The main thing is you got to put the information on the velocity time graph and use that graph to figure out the answer to the question. Finish up the next minute or so, then we'll go over it. So how many people got an acceleration of 1.4 meters per second? Couple. How many people got a distance of 280 meters?
I got 28. So
Okay.
500. Oh, I just didn't divide it by 2.
Okay.
Because I got 560.
Yeah, so Christopher Robin's 1984 Buick Century, that's in there because that was my first car, can accelerate from rest to a speed of 28 meters per second in 20 seconds. So he is starting from rest, and he's going up to 28 meters per second. And that takes place over the span of 20 seconds. So, if that's true, in order to find the acceleration, we just got to get the slope. So the slope is rise over run. In other words, 28 over 20. And that comes out to 1.4 meters per second squared. That's his acceleration. As far as the distance traveled goes, that's equal to the area trapped by this graph. So we just calculate that area. It's a triangle, so we do 1/2 base times height. Base is 20, height is 28. When you do the math, you'll get 280 meters. So he's traveled almost 3 football fields. Questions on number 1? All right. Number 2 is about Tigger. So go ahead and try and finish number 2. I'll just give you maybe 2 minutes at most for this one. There's only one part to it. See what you can do. Anybody get negative 2.67 meters per second squared?
Hold up.
Okay, so let's go over this one. So Tigger starts with a velocity of 30 meters per second.
Oh, no.
And he ends with a velocity of 14. And that takes place over 6 seconds. So then the question is, what is his acceleration from 0 to 6 seconds? So acceleration from a velocity time graph is just the slope. So we got to do rise over run. From 30 to 14, we've gone down 16 meters per second. So for the rise over run, the rise is negative 16. The run, of course, is 6. So negative 16 over 6 is negative 2.67 meters per second squared. Tigger's got a pretty good acceleration there. Next up, go ahead and try number 4. This is about Roo. That's the little mini kangaroo.
Oh, let's see what's going on
Anybody get an acceleration of 5?
Yeah.
Very good. Or actually, time is 5, sorry. Yep. And then for change in distance, anybody get 50? Very good. So let's see. Roo has a speed of 20 meters per second, so he's starting up here. He slows at a rate of 4 meters per second squared. So we got to figure out how long it takes him to stop. So that's what we're trying to figure out here. So the main thing we got to think about here is what this slope is equal to here. So acceleration is equal to rise over run. So we know what the acceleration is. The acceleration is 4. I suppose negative 4 would be the proper way to say it. Negative 4 is the acceleration, and that's equal to rise over run. We know the rise is going to be negative 20 because we're going from 20 to 0. But we don't know the run. And that's what your time is equal to. So in order to solve for this, you're going to multiply both sides by t, divide both sides by negative 4. Negative 20 divided by negative 4 is equal to 5 seconds. So that would be your time for this one. Yep. And then for the change in distance, now that we know this is 5, we can figure out the area that's trapped by this. 1/2 base times height. 1/2 times 5 times 20 is equal to 50. 50 meters. That's a long way for a little kangaroo to go.
Dude, he goes crazy.
He does. Is kangaroo a boy or is Roo a
I
boy?
think he's both.
I actually don't know. I think he is.
It's up for him to decide.
Almost positive Roo is a boy. Okay, let's finish up with number 8, or number 6. Do number 6 with Piglet. I'll just give you 60 seconds. We'll go through it quickly, and then we'll get to some fails. All right, that's long enough. Let's take a look at number 6. So if you did get to an answer, the first answer would be 1 for the acceleration. The distance would be 77.5. So let's take a look at that. So Piglet runs down his walkway with an original speed of 5 meters per second, and he does that for 8 seconds. So he starts at 5 meters per second, and then he keeps that speed for 8 seconds, and then he increases his speed to 10, and that occurs over the span of 5 seconds. So now you're at 13 seconds total. Any questions on where this graph came from? Wonderful. So the first question then is, what is his acceleration? Well, the acceleration is equal to the slope here. So the slope is rise over run. We've gone up 5 meters per second, and we've gone across 5 seconds. So that gives us an acceleration of 1 meter per second squared. So that's our acceleration. In terms of the distance traveled, you have to realize that we've got 2 shapes here, because to find the distance, we calculate the area that's trapped underneath. So we have ourselves both a rectangle so we need to find this area, and we've got a triangle. So we'd have to combine both of those areas. So for the rectangle, base times height, 13 times 5. Triangle is 1/2 base times height, so 1/2 times 5 times 5. And when you add all that together, you should get a total distance of 77.5 meters. And that is how far Piglet has gone. Also a big distance for a little piglet.
They just be stopping different.
Probably. He's in good shape, I bet.
Cross country woman.
Well, he's got to keep up with Pooh all that time, so I'm sure he's in real good shape.
Well, when you have Boots like